Hey everyone, so on your block class this week, you looked at ratios, and ratios were simply a comparison of two quantities. So looking at how two quantities were related to one another and comparing those. This class, we're going to be looking at proportions. So basically a proportion is basically a way to check and see if two ratios are equivalent or equal to each other. So proportions are really two equivalent ratios. And we've got a couple of different strategies, and this is in the notes that you have in front of you. A couple of different strategies that we can use to see if two ratios are proportional. So the first one, thinking of ratios in that fraction form, is very similar to what you've already looked at this year with fractions and finding equivalent fractions. So the first thing we could do is see if we could simplify them and if they simplified into each other. So if we were looking to see if 2 to 3 was equivalent to 12 to 18, we could simply just simplify 12 to 18 down like a fraction. We're thinking of it as 12/18ths, and see if it simplifies to 2 to 3. And if it does, then those two ratios are in fact what we call proportional. Another strategy that we can use is we can look for a common multiplier. So if we're checking to see if these are equivalent ratios, I would simply look and see if I could multiply straight across. So to get from 2 to 12, we can multiply by 6, and we would just check and see, are we multiplying by the same thing on the bottom, kind of like if we were making equivalent fractions, to see if those were in fact proportional. A lot of times though, we might not have the option to simplify or multiply straight across because the numbers don't work as nicely. So the biggest way we're going to check, and the way that's going to check or work all of the time when you're looking at proportions, is to check the cross products. So basically cross products is looking at these diagonals and multiplying those together. And the trick here is if those two diagonals multiply to be the same thing or the same number, then they are proportional ratios. So here I'm looking at 2 times 18, which is 36, and 3 times 12, which is also 36, and because those two diagonals are equivalent, those ratios are proportional. My last method would be to convert them to decimals, which we don't use as frequently, but to convert a fraction into a ratio that's in fraction form into a decimal, we can just divide the numerator divided by the denominator, and if you use your calculator to do that with both ratios and they're equivalent, then those two ratios are proportional. Most of the time we're not going to be checking two ratios to see if they're proportional. We're going to use one of these strategies to solve for a missing piece in a ratio. So for example, down here, if I was looking to see what to 4 is equivalent to 6 to 8, we could use this idea of a common multiplier and say, well, to get from 4 to 8, we needed to multiply by 2. So what times 2 gives me 6? And the answer there is 3. 4 times 2 is 8. So 3 times 2 is 6, so 3 is the missing piece. The other thing I can do, and this is the area that we're going to focus on a lot today, is use those cross products to solve. So basically, if we're looking for the value of x here, and again, this cross product strategy is going to work for every single situation, okay? Common multipliers are not going to work all the time depending on your numbers, so if you're looking for a one-size-fits-all method, the cross products is what you're going to want to use. So basically what we're going to say here is that 8 times x is equivalent to 4 times 6. Well, we know 8 times x is just 8x, and 4 times 6 is 24. And then if you look at what you've just set up, is you've got a one-step equation, which we've just got done solving. So to solve for x, and to get x by itself, we're just going to divide by 8 on both sides to find that x is 3, or my missing value is 3. So let's try a few together. So again, if I'm going to check and see if two ratios are proportional, okay, I could look for a common multiplier, but as we see here, 6 doesn't go into 15 evenly, and 4 doesn't go into 10 evenly, so that doesn't really work. So if we check those cross products, basically we're going to say 10 times 6 is 60, and 15 times 4 is also 60, and since 60 and 60 are the same cross product, these two ratios, 15 to 10 and 6 to 4, are proportional. We can do the same thing over here. Again, 14 doesn't go into 21 evenly, so a common multiplier doesn't work. But if I check these cross products, 10 times 21 is 210. 14 times 3, I might not know off the top of my head, but I do know that it's not going to equal 210. It's not going to come anywhere close. So these two ratios are not proportional because their cross products are not the same number. So that's, again, if I'm checking to see if they're proportional. We can do the same thing here, okay? 2 times 2.1, I can even use my estimation skills. 2 times 2.1 is going to be 4.2, and I know 9 times 1 point something is going to be bigger than 4.2. So again, I've got two ratios that are not proportional. Over here, if we check this, we know 8 times 6 is 48. 16 times 3, if I plug it into my calculator or use my mental math, I get 48 again. So 8 to 16 is equivalent to 3 to 6. Now some people look at this one and they can real quick see, oh, 8 to 16 simplifies to 1 to 2, and 3 to 6 simplifies to 1 to 2. If you can look at that right off the bat and recognize that, you don't need to check your cross products. You can see that because they simplify to the same simpler ratio, they are going to be equivalent. All right, so now let's look at this cross products to solve for a missing piece. So again, I want to set my cross products equal to each other. So basically what I'm saying here is that 15 times m, or 15m, is on this diagonal, and I need to set that equal to 36 times 10, which is 360. So again, that was my 36 times 10. Now it's just simply a one-step equation. So I'm going to divide by 15 on both sides, and when I divide by 15 on both sides, I get m equals 24. So I know that a 24 to 36 ratio is equivalent to 10 to 15 is what I'm just solving for. And we're going to look in a few minutes about when we would use this, what types of word problems or scenarios we would apply this to. All right, so I want you somewhere in your notebook to jot down these two proportions and see if you can use cross products to solve these. So again, take out your notebook if you don't have it out already, and we're going to jot these down. If you think that you want to attempt these on your own, go ahead. If not, I'm going to walk you through these two problems. So again, you can attempt this on your own, or you can follow along with me. So for this first one on my first diagonal, I'm going to have a times 14, which is 14a. In my other diagonal, I have 11 times 10. Well, I know 11 times 10 is just 110, which is equal to 14a. And I'm going to divide both sides by 14 now. And when I do that, I get a equals 7.86. Now right off the bat, people always think they're wrong because I get a decimal, and if I'm writing it in fraction form, we can't have decimals. But we need to keep in mind that we are looking at ratios and proportions now. These aren't truly fractions, so it is okay to have a decimal response. So this decimal went on forever. I just rounded to the hundredths place, and I'm going to move on. For my second one, I'm going to have 6n is the same as 14 times 5, or 6n equals 14 times 5, which is 6n equals 70. If I divide both sides by 6, I get n equals 11.6 repeating. So same thing, it's not unusual to get decimal answers when we're working with ratios and proportions. That's okay, you just write it down and we're moving on. All right, so what we need to look at is how we're going to use ratios to figure out problems. So here's a perfect example. It says in the 6th grade, there is a 3 to 2 boy to girl ratio. If there are 80 total students in the 6th grade, how many boys are there and how many girls are there? So we're looking at a part-to-part ratio here, and we're comparing it to a total or a whole. So really when I go to solve this, in my 3 to 2 ratio, the total parts is 5. 3 boys plus 2 girls is 5 total. So again, in that 3 to 2 ratio that I'm given, it's got a total of 5. But we're trying to figure out how many of each gender there are when the total is 80 students. So we basically are figuring out how many times bigger the whole needs to get to make it from 5 to 80. So basically, if I'm taking my original ratio and trying to make it out of 80 total instead of 5, how many times bigger is that? Well, 5 goes into 80 16 times, so it's 16 times bigger. So all I need to do here, and we're going to set up proportions in a minute too, is we're going to make that ratio 16 times bigger. So basically I'm taking my 3:2 ratio, which was a boy to girl ratio, and I'm multiplying each of those by 16 to give me 48 boys and 32 girls in the 80 total student body. Let's look at a couple more. We're going to look at 2 word problems so that you can get the handle of setting up these proportions before you solve, and then you're going to do some practice with a partner today on solving with cross products and then also solving some word problems. So this one says Julia is planning to serve hors d'oeuvres at her wedding. So those are kind of like appetizers. She plans on offering 8 hors d'oeuvres for every 3 people. If she has 240 people RSVP to the wedding, then how many hors d'oeuvres will she serve? So we need to start kind of like we've done with our equations and inequalities, looking at what information I know. So I know that there are 8, I'm going to abbreviate, hors d'oeuvres for every 3 people. And I also know that there are going to be 240 people. If I go to the question is asking me how many hors d'oeuvres. So I might say H is going to be the number of hors d'oeuvres here. And I'm going to abbreviate that. So now we're going to set up the proportion first, and then we're going to use our cross products to solve it. So the first thing you should always do when you go to set this up, unlike an equation or an inequality, we want to get our proportion prepped. So what I'm going to do is I'm actually going to start by setting up the labels. And I'm going back to the information, and what it's telling me is that I'm comparing hors d'oeuvres to people. So I'm just going to say off to the side here, without using numbers, that I'm comparing hors d'oeuvres and I'm comparing people. And this step, setting up those labels, is really, really important because now I know that anytime I have a number that's dealing with hors d'oeuvres, it's going to go in the top of my proportion, and anytime I have a number that's dealing with people, it's going to go on the bottom. So I'm going to then write the given ratio. So the given ratio in the problem was 8 hors d'oeuvres for every 3 people, and I'm setting up a proportion, and the other piece of information I have is that there are 240 people. So I'm going to look back at my labels, and I can see that I put people on the bottom. So I'm going to put the 240 people on bottom, and then H, my variable, was an hors d'oeuvre thing, so that is going to go on top. Now that I set up that proportion, it's just a matter of using those cross products to solve for the missing value. So I'm going to say that 3 times H, or 3 times my variable, is equal to 8 times 240, which is on my other diagonal. So I'm going to do that multiplication. 8 times 240 is 1,920, which is equal to 3H. And I'm going to finish that off by dividing by 3 on both sides to give me H equals 640 hors d'oeuvres. So my solution then would say something like Julia will serve 640 hors d'oeuvres at the wedding. If we look at one more, let's look at one more word problem, setting up that proportion, okay? And solving here. So it says there, in class 1, there are 9 girls out of 15 students. So it's giving me a girl to student part to whole ratio here. If this stayed consistent, meaning that it's going to stay proportional, how many girls would we expect to have in the 6th grade class of 75 students? So again, the first thing I want to do is set those labels up. What are the 2 things I'm comparing? Well, I'm comparing the number of girls to the number of students. So I'm going to say it's a girls to student ratio. And the first ratio that's given is a 9 to 15 ratio. There are 9 girls for every 15 students. And then the question says, how many girls would I expect to have? So my variable might be up top with the girls in a class of 75 students. And that 75 goes on the bottom with my students. Again, once I use those labels and set up that proportion, I'm going to do my cross products. 15 times x equals 9 times 75. So that gives me 15x equals 675. And my final step is going to be to divide there by 15 on both sides to give me x equals 45. So out of 75 students, if that ratio stayed the same, I would expect that there are going to be 45 girls total in that student body. So this is what you're going to practice today with your partner, okay? You're gonna be looking at a proportions worksheet. On the front side, you're simply solving the proportions. So you're gonna try to find the value of the variable using that cross products or maybe multiplying across, whichever you're comfortable with. Again, the cross products will work every single time. Multiplying across will not. And then on the back side, you've got 8 proportion word problems to attempt. I started it off for you on the first 3 to kind of get you started on those and show you what the setup looks like. So use what I started for you to help you solve that. And then once you're finished with your partner, the answer key is on Schoology. You're able to check those when you're finished. All right, have a great day.